very warm welcome, and as we bring Marina onto the stage.
All right, good evening. It's good to see all of you here. Now, before we begin, I want to do a quick experiment with all of you today. Now, in a second, I'm going to ask you to put your hand up while I throw certain statements at you. And if you agree, you're just going to keep your hand up for me. Okay, so can you put your hand up for me if you own a smartphone? That's basically everyone in the room, and you can't lie to me because I've watched you use it for the QR code, okay? And I want you to keep your hand up if you used your smartphone today for something like sending an email or reading an email or maybe Googling something or even looking at the weather. Again, that's nearly all of us. And just engage your cores for this last one. I want you to keep your hand up if you used your smartphone to do all of those things instead of going to your local library to get that same information from a book or waiting for the news presenter to tell you the forecast for the day because it was easier and more efficient. Again, that was all of us. Thank you very much. I'm going to ask you to put your hand back down. I saw some of them were kind of getting tired, but on the bright side, you don't have to work that hand out at the gym tomorrow. I hope it was easy to see that technology has become ubiquitous with the way that we live our modern life. And I want to tell you today about how tech is changing the field that I work in. Now, I'm a chemist, and chemistry is the science of making new things. Whether that is new materials with weird and wacky properties that nobody's ever made before, or more recently, drugs and vaccines to tackle a new infectious disease. Or perhaps it's even the latest scent of that candle that you really like. I guarantee you that at some point in the development process, a chemist was heavily involved. Now, but before I can tell you about how technology makes our life easier, I need you to understand what a day in the life of a chemist looks like. So we have our little time axis that takes us through the day. And typically, a research chemist will come in the morning and they will start to prepare their reactions. And I want you to think of this process a little bit like cooking, okay? So you're going to make a cake with me today, and that's going to be our chemistry. So you'd weigh your ingredients out, and then you'd mix them together, and you'd stick it in the oven, and then you'd wait for your cake to bake. And for us chemists, that means it's coffee time. All right, we come back from our coffee break, our cake is ready, our chemistry is done, and we work it up. And typically that's a purification stage, so you can think of that as decorating your cake. And then we need to dry our chemistry, okay, to get the final product out. So you may think of that as putting your final cake in the fridge before you can eat it, okay? And while our stuff is drying, it's ample time for another coffee break. And when we come back, we have time to do analysis. And we rinse and repeat this cycle 2 or 3 times a day to make new products and new materials that serve you. Now, we could do all of those things by hand. However, that takes an awful lot of time. And what the digital revolution has allowed us to do is to optimize our workflow. We have wonderful robots, gizmos, and gadgets that automate the boring side of things so that we can focus on the important. We've created dispensing robots, which essentially let you prepare thousands of cakes in 1 hour or so. We've also made programmable hot plates. This is a bit like you being able to control your oven while sitting at your computer, and it will even send you an email when it's done. Wouldn't that be great? I'm here busy doing stuff while my dinner's cooking and I get a notification to say when it's done. We have automatic purification systems, so fancy machines that decorate our cakes for us, and rotary evaporators, which also automatically dry our chemistry. And lastly, we've created a whole host of machinery that does analysis for us in the lab. And all of that means is that we spend less time on preparation, workup, and drying, and more time on coffee. But we don't just drink more coffee. We can also have time to do more analysis on our samples. And what that means is that we can start to produce better quality data, and we can produce more of it. And what that means is that we can start to focus on complex chemistry, the things that can't be automated and the things that matter. And what we can also do is we can learn, plan, and develop as researchers so that we can better predict what the future world might want. And all of that kind of takes us to a very efficient setup of our workday. We save a little bit of time by doing all of these things. Now, that is the good news. However, I'm very jealous of all these chemists that are able to use this technology. Unfortunately, I am not one of them. I'm an inert chemist. Now, you may be wondering, what is inert chemistry? We spend our time fighting against the things that you don't think about. Our chemistry is really sensitive to air and water. So we spend our days, like brave warriors, trying to get rid of it out of our reactions. And we do that with some pretty interesting stuff. We use specialized glassware that's completely sealed off to the outside world. We use these funky looking things called glove boxes, which are just humongous boxes that take up a whole room that you stick your hands into, and there is no air inside of it. Instead, we use gases like nitrogen and argon to make sure our chemistry is safe. And most importantly, we use these things called Schlenklines. Now, Schlenklines are available in most inert laboratories, and we use them to remove the air out of our flasks and to backfill them with our inert gas to, again, keep our chemistry nice and safe. Now, you've already seen this before, and the day in my life looks much the same to that of a normal chemist. However, there is one caveat. We cook our chemistry in much the same way. However, we can't do that with automation. So, let me walk you through. And for the sake of time, we're just going to look at the preparation stage. So where we mix and combine our chemicals to set our reaction up or to get our cake in the oven. And for us, that starts the night before. We need to remember to dry our glassware. For you, that's like putting on your oven the night before you want to bake a cake to make sure it's warmed up enough. A little bit tedious. Once we've done that, we come in the next morning and we take that glassware out of the oven and put it into the glove box. And that might not mean a lot to you, but what I want you to remember is that every time this red clock appears, that is us paying a time penalty, okay? I want you to imagine that you and some of your friends gather together to play Mario Kart. And this time penalty is all of your friends playing and you're sitting and waiting for 20 minutes to start. They're already finished and got their first place, and you're still number 12. So we do that, we take our glassware into the box, we weigh our materials out, and we take them out of the box and we pay another 20-minute time penalty. And then we put our reaction on, and yet another time penalty we have to pay. And all of that happens before we've even got to the interesting stuff. So to me, I'm already an hour behind what the normal chemist has done. They've maybe got a reaction set up, they've maybe done some analysis, and I'm still there waiting. So what our group is doing, and what my research is that we've started to automate the impossible. We've created this fancy bit of glassware with 3D printed bits and coded things and gizmos and gadgets combined together into this thing we call the AutoSchlenk. And what the AutoSchlenk allows us to do is it allows us to automate some of that preparation time so that we're not waiting around as much, but also to optimize the drying process by automating it. And to us, that doesn't just mean more coffee time, which is great. It means that we can tackle more challenges. Now, in our lab, we really like to work with spicy chemicals. We really like radioactive materials like thorium and uranium, and we really like highly toxic things. Now, I myself, and probably you, don't want to be exposed to those things. And what our technology allows us to do is to take a little bit of a step back and not be exposed to these materials. And in return, what we can do is we can begin to understand these materials better. And particularly, we like to employ this technology to understand radioactive waste. And if we can understand radioactive waste and how it forms and how it behaves, we can start to safely dispose of it, okay? And what I want to leave you with today is that not only do we get more coffee by automating things, but we also make our chemistry safer, and we make the nasty stuff easier to work with. So we are taking the fear out of chemistry. Thank you.